Okay, so my project was about visualizing casino simulations. And we're going to visualize a couple different uh, casino games. But what we want to get here is we want to get away from this idea in our head of just the flat percentages or expected losses, right? So in roulette is, a 5% edge for the casino, which means you should expect to lose about $5 on a $100 bet. So you do, let's say, $10 10 times. The expected loss is $5. That's the mean, though, and we don't really think about what that means over the long term, and we really don't think about what these very low probabilities do with these payouts. And there's kind of a nefarious um, some trickiness going on here when we look at these under the microscope when we visualize these. So let's just take red and black really quick. So basically what we did, we just created a way to simulate the payout for red and black. And basically we're just taking, if a player gets, just generating a random number, and if the random number is red or black, we just say, okay, return the payout. If not, give them nothing. And just spinning with the random number. And then what we're going to do is we're going to just simulate a certain n number of players playing n number of games with a certain bet. And almost all of these are just $10 bets. And so let's say we simulate 1,000 roulette players betting $10 each on 100 games. So you get kind of this just normal looking distribution. You have a little bit of a problem here because so many people break even that it's skewing the histogram, making it look like you have a better chance of breaking even or gaining money than you do losing. So we went ahead and just used a Altair chart, split this up down the middle here, so you have between -10 and 10. And a lot of people do end up splitting even or getting even, but you can definitely see that there's a good chance of loss here. Now, playing 10 games, you see that, okay, yeah, the expected value or the expected loss is around $5, but there's a good chance you're going to start losing. There's a good chance you can lose $30, $50, and there's still a chance, that you can, get into the 70s or 80s. But I didn't feel this was the greatest way to present this. And box plots didn't really do that well either. It just looks like a normal distribution centered around 0. And so I upped the simulations a little bit, 100 games each. You see this normal distribution, but and you see it's kind of reaching the 50 mark, but this is not showing exactly what is going on in roulette, because roulette is more than just red and black, right? And you can see after a long time, the winners or the losers really outnumber the winners. But there's some really nefarious things going on when you start adding in other bets here. So let's go through the other bets. And so just to give a little bit of an example, some of these bets, they're 9-to-1 payoffs. A straight up bet, which is just one number, is a 36-to-1. Why is that so crazy? Why does that cause really interesting problems? So let's look at this. And so, by the way, so we created just random strategies generally. We didn't use any specific strategy. All strategies at casinos are going to have a negative expected value for wins, but we generated random ones. There's a million that you could do, but we're just generalizing here. But if you just generalize random strategies, and you look at what if you play one game with those random strategies, you get this interesting tail here, because what's happening is that, okay, a lot of people get nothing. And then you have some people getting way out here. And you can see there's kind of these humps here. And this hump is more than likely due to somebody hitting a 1 to 36 payoff on a straight up. And so that's paying for a lot of their fails down here. Now this L shape here is actually pretty nefarious because we get down here and we start looking at some spins. Okay, so one spin, you have, this long tail, and you have a lot of losers and a couple winners. But all of a sudden, 10 spins, you have more winners and less losers. And, the evens have gone down. So what is happening here? How do you have an increase in the amount of winners when you increase the number of spins? The house should have the edge over the long term, right? What's happening here is because of this long tail, these people might still might lose money over the long term, but they're just getting shifted slightly over. And that's what you're seeing here as this tail kind of winds out a little bit, and you start seeing the skew. And so if you think about this logically, what's more of a chance of you becoming a winner in roulette? You play one game and spend 1 to 30, or have a 1/38 chance of getting your one number, or doing it 10 times. Well, the obvious one is 10 times. But what's your expected loss in that situation, right? You're still having higher expected loss. So what's happening here is that you're having more winners, but the losers are eating up more of the losses. And that's continuously happening as you go down the line here. You're actually getting people with huge losses. And you start to see this really in this graph here. So over the number of games, you start to see some people just losing ridiculous amounts of money. 1,000 games, some people are losing, $30,000 here. And the winners are just barely making any money. And so that's really nefarious in the way that casinos are kind of working. Now, granted, that it's part of the model of casino, but still, it's very, very tempting psychologically when some people are winning and then some people are just losing wildly. And there's also an asymptote with winners as well, which is interesting because there's always some chance that will be someone beating the house even after so many games played. So it's asymptotes at once. So you can always see winners at the casino even after many games playing, which is dangerous because people can believe just putting more money in will win. And so we also looked at Baccarat, and Baccarat doesn't have this to the extreme, but Baccarat does have this to a certain amount. And Baccarat is played kind of like blackjack, but in a sense, all you're really betting on is the banker or the player, and you don't have any control over what happens. But basically, you see the same kind of tail here going on with 10 games, 100 games, 1,000 games. And the reason why is because the even bet gives a large payout 1 to 8 versus a banker or player bet, which is a 1 to 1. So these large payouts at casinos can be very serious. They create more winners for casinos, but they create losers that just lose a lot of money. And here we can see the different graphs as well for these. And here we can just look at the different games. So if you're playing for player, if you're betting on player, you have a very small distribution. For the banker, very small distribution bet. But you're betting on ties, large distribution, and you see that it can kind of override some of the other bets that are happening. For blackjack, I wanted to do something a little bit different for this because I wanted to handle counting cards. And, so for the average player, you have about a 2% disadvantage. Perfect play, so knowing all the strategies involved without counting any cards, you have about a 0.05 disadvantage. For counting cards, you have about a 1.5% advantage. But even knowing those statistics, it's completely possible to be ahead in 1,000 hands of the average player and to be way behind counting cards in over 1,000 hands. And I wanted to create kind of some charts to kind of create and look at that and how frustrating it can be for someone who's counting cards. There's plenty of dips where you're in the negatives here over time. For someone at 5,000 hands being negative counting cards, this gets dangerous, because what you can end up happening is that if you're in a casino, you can be drinking alcohol, or um, you could run out of money in your bankroll. You can mess up your strategy. Any of those things, you all of a sudden become a perfect player, an average player, and you start losing money. So I thought this was very neat to look at, as far as some of the psychology and tricks in the math here in casinos. We don't really think about. We think casinos lose, or players lose money, but we don't think about how much some players might be losing, and we don't think about the tails that are going on. So, but that is my presentation. Thank you very much.